Today in class, we use completing the square in a little bit different way. Instead of using it to actually solve for x, what we used it for is to rewrite our equation from standard form, ax squared plus bx plus c, into vertex form, which is y equals a times x minus h squared plus k. And that will allow us to identify that vertex, which is that hk, much more quickly. And so here's how we can use completing the square to do that, okay? So we're going to work through this example. It says write y equals x squared minus 10x plus 22 in vertex form, and then identify the vertex, okay? We are going to complete the square. We're only going to be completing it with part of the problem. We're not using it to solve. And if you remember from yesterday, we're really only interested in working with the x terms. So when it says to prepare to complete the square, what it really wants you to do is isolate those x terms away from the 22, but leave a blank for the new value that's going to go in to make it a perfect square. However, remember, if you're adding something new to this side, we also have to add something new to that side. And so that's really what they're talking about with preparing to complete the square. Just set the problem up. And then if you look at the next step, this is exactly what we did yesterday. Take your b value, divide it by 2, and square it. And for this problem, we will get an answer of 25. And that is what will go into the blanks. Okay. And if you now notice that what is in the parentheses is one of our perfect square trinomials, which we can then factor down into 1 parenthesis squared. And for this problem, x squared minus 10x plus 25 will factor down to x minus 5 squared. And you can see it's starting to look like vertex form. And so the last thing we really have to do is just get the y by itself. We can do that by subtracting the 25. And so your final answer ends up being y equals x minus 5 squared minus 3. And from there, we can then identify our vertex as being the point 5, negative 3. Looking at one other example, just to give you an extra example. Again, on your first step, just get it set up and so that we are prepared to actually complete the square so that we have a perfect square trinomial. All right? And then from there, we can find our b divided by 2 squared value. And that is what will go in the blanks. And then from there, this is now a perfect square trinomial that can be factored down to x minus 4 squared. And when I subtract 16 from both sides, my final equation in vertex form is this, which gives me a vertex at the point 4, 1.